Hey guys, so sorry we don't get to see each other today, but I did make this video to help us finish up the notes that we were so close to finishing last class that I saw you. Last class, we completed the first page, the back of the first page, and the first section on the second page, which I labeled section number 3. We should have all finished that. Some of you finished section 4, the bottom half of that page, and then some of you did not. So this is a video that you can fast forward, you can pause, whatever you need to do. You can make it go slower, you can make it go faster, to help you finish up the notes. It's going to take us maybe 10, 15 minutes. Okay, it's not supposed to take us very long. You are responsible for filling in these notes just as if we were in class. I am not doing this when we come back on Thursday, so you need to finish doing that. It won't take very long, I promise. I did post a filled-in copy of these notes in Canvas today, so if you weren't here last class or if you lost them, they're there, so you can find them again. So let's start with the bottom of the page 2, section 4. It says converting between moles of a compound and moles of an element. So remember, these notes are set up where we're just going to do like a formula first, and then we're going to do a practice problem. But that formula is supposed to help you set up any problem you may have. So for example, for number 4, you're going to start with the number of moles in a compound. They're probably going to give you that number. And you want to go to moles of an element. So if you want to go to moles of an element, we're going to set up our formula as such. We want moles of a compound to cancel out, right? And to do that, we're going to put 1 mole of that compound on the bottom. And then you're going to put the number of moles of the element that is present in the compound. That's usually in a subscript little number next to that element. That is the number of moles that you're looking for. Remember, this is a ratio. We talked about ratios when we were doing the POGL. The ratios are going to help you decide how many moles are there of a element compared to in the compound as a whole. So let's do a practice problem using this formula. Our question is, what's the number of moles of oxygen in 1.7 moles of CaCO3? So our question is the number of moles of oxygen, what we have. Remember, I always start with what do we know? We know 1.7 moles of CaCO3. If I want to know how many moles of oxygen there are, first step in our formula, we need to write down 1 mole of CaCO3 that goes in the bottom so that our moles of CaCO3 will cancel. And then we're going to be left on top with what we want. We want to know how many moles of oxygen there are in CaCO3, right? So if you look at this formula, look at the little subscript next to oxygen. There's a 3 there, right? That little subscript is what we're looking for. That means there are 3 moles of oxygen in 1 mole of CaCO3. So we just found a ratio, a 3-to-1 ratio. Just like when we were weighing the eggs, the chicken eggs versus the quail eggs. For every mole of CaCO3, there are 3 moles of oxygen present in CaCO3. That's the same thing, that's what it's looking for. So in this problem, we're going to multiply, right? We're going to multiply 1.7 times 3. You should get something around 5.1 moles of oxygen. Remember, we care about significant figures now. There are 2 sig figs up here in the problem, so my answer needs to have 2 significant figures in the end here. And you do need to label moles of oxygen, because I need to know how many moles of what? Moles of CaCO3, moles of CO3, moles of calcium. No, we care about oxygen right now. This is moles of oxygen. All right. Let me clear the screen. Remember, you can always pause this video and make sure you have everything written down. If I miss something or it's unclear, you can always email me, okay? Okay, now we're on the second half of that section. What happens if you're given the number of moles of an element and you want to go to moles of a compound? So let's set up this formula. We want moles of the element to be on the bottom of this formula so that they cancel out, right? So we're just flipping these from what we did last time. We're just rotating. We're going to figure out the number of moles of the element in that compound, which is the little subscript number next to it. He goes on the bottom so that we can cancel those guys out. What we want goes on top. I want moles of a compound. So 1 mole of that compound goes on top. All right, let's do a practice problem. Determine the number of moles of H2SO4 that can be produced from 5.6 moles of hydrogen. So we want to know the number of moles of H2SO4 when we have 5.6 moles of hydrogen. That's what we know, right? So I wrote down what do we know. Based on our formula up here, let's decide. Look at H2SO4. You want to look at the little subscript. How many hydrogens are there? There are 2. So we want to write the number of moles of hydrogen on the bottom. There are 2 moles of hydrogen. And that's for every 1 mole of H2SO4. So again, we came up with a ratio. For every 1 mole of H2SO4, there are 2 moles of hydrogen. Okay, so you're going to divide here, right? You're going to take 5.6 and you're going to divide by 2. You should get something around 2.8 moles of H2SO4. Remember your significant figures. Okay, so that finishes up section 4. You're going to flip your page now to the very back of the notes, and it's going to look scary. Don't panic, we're going to take it one at a time. Okay, again, don't panic. It would look less scary if I were doing this with you on the board in class, like normal, but we will do it one little step at a time. So, we are now going to think about if we want to convert between mass of a compound and mass of an element. These are the hardest ones you're probably going to have to do. If you can do these, you got this. If you're stuck on these, I'll help you get this, and you'll be fine, I promise. So, let's change to purple. All right, purple pen. So first thing we're going to do is we are going to write our formula, right? One note I wrote here is that these could also be molecules, so like number of molecules. It doesn't have to be a mass. So if you have a certain number of molecules, you could use the same formula to figure out molecules. Okay, so we have to do 3 conversions here. This is the most that we'll probably have to do is 3. So at some point, you're given the mass of a compound. All we're doing is we want your units to cancel so that we end up with what we want in the end. That's all we have to do. So it's not like you have to memorize this formula. Think logically about what will cancel out so that you can get to molar mass in the end, the mass of an element in the end. So first step is we're going to take this mass of a compound and we're going to convert that mass in grams to moles of the compound. How do we do that? Take the molar mass of the compound, which remember you calculate based on the periodic table. And that's going to be in grams because molar mass, remember, is grams now because we're dealing with moles, not individual little elements, not AMUs. AMUs get converted to grams in molar mass. So you're going to put the molar mass of the compound, the grams that you figure out, on the bottom. That will then cancel out with the mass of your compound because that's in grams, right? On top, we're going to put 1 mole of that compound because for every mole of the compound, it'll have a weight. It'll have a grams associated with it based on the molar mass you calculate. Okay, so now we're going to end up with moles of that compound on top, which is what we want. Now we're going to convert moles of that compound into moles of an element. So we're going to take the moles of a compound, the 1 mole of a compound, those will cancel, right? And then on top, you're going to put the number of moles of the element in that compound. This is just like what we did on the back of the last page, right? We tried to figure out the little subscript of the number of moles of the element in that compound. Okay, that will convert your answer into moles of the element. We're not done yet because we want the mass of the element. So, logically, 1 mole of that element is going to go on the bottom because that'll cancel this guy out, right? And then to get the mass of that element, you look at the periodic table, figure out the molar mass of that element. And that will be in grams. That's what we want our answer to be in, is grams of the element. So that's where we stop. Your answer will be converted in the end to grams of that element. All right, so basically, we just merged two of the things we learned in these notes together. We're just combining the steps in one. Go. So, let's try a practice problem. What mass of carbon is contained in 55.4 grams of carbone, which is C10H14O? So, my question, what's the number of grams of carbon in C10H14O? We write down, what do we know? We know 55.4 grams of C10H14O. I know this looks scary. I kind of ran off the page here, so I'll try to guide you to where I'm looking. The first step, we need to figure out the molar mass of our compound. So you're going to go to the periodic table. You're going to figure out the mass of carbon, and you're going to multiply it by 10, right? And then you're going to go to the periodic table, and you're going to find hydrogen. And you're going to determine the mass of hydrogen. You're going to multiply that by 14. Sorry, my pen's not great here, guys. Doing my best. Okay? And then you're going to find oxygen. And you're going to determine his mass. There's only one of him. He should be 16.0 grams. Oof, terrible. You can make fun of me later. Okay, 16. And then you're going to add all those masses together. I know you guys can do that. We did it last time. You should get a mass of 150.2. Remember, the consensus we came up with was give me the exact mass based on the exact values on the periodic table. So there's 150.2 grams of C10H14 and O. That is the total molar mass. He goes on the bottom. That should cancel that part. And that's per 1 mole of C10H14O. So for every mole of C10H14O, we have 150.2 grams. Okay, first step done. Second step, we want to get those moles of that compound into moles of an element. So this is where we define our ratio. We want 1 moles of carbon, C10H14 on the bottom, because we want those to cancel out, right? And now we want to figure out the number of moles of the element in the compound. So if you look at our compound, how many carbons are there? There are 10. So that's 10 moles of carbon. He goes on top. Because we're trying to figure out what's the mass of carbon. So carbon's the only one we care about. Now, your answer will be in moles of the element. But we're not done yet because we want to go to the mass of the element. How do I figure out the mass from those moles? Take 1 mole of carbon. What is he equal to on the periodic table? His mass is 12.01 grams for every carbon. For every 1 mole of carbon. And you know this is mole because this is in grams, not AMUs. All right, and then you're going to divide and multiply. Whatever you need to do. You can do it all in one run. You can do it one step at a time. So you could do 55.4 divided by 150.2, hit equals. Then you can multiply by 10, hit equals. Then you can multiply by 12.01, then hit equals. Or you can put all of this in your calculator at the same time, and it should still work. You can go ahead and test it for me. You should get 44.3 grams of carbon. Remember our sig figs. There are 3, so I want 3 in my answer. Okay, I know that seemed very scary and a lot of work, but once you practice a little bit, it'll come. I did also post some videos to help you walk through other problems if you want to watch them. They're at the end of this module, so if you want to watch other examples, go for it. All right, I'm going to go to the next section, and that's the last section. Okay, so what if we have the mass of an element given to us, and we want to figure out the mass of a compound now? So again, we're kind of like reversing this order, okay? So if we are given the mass of an element, it's a number. How we set up our formula. We want the mass of the element to cancel with the bottom, right? So you're going to find the molar mass in grams of the element so that your mass of the element cancels. And that's for every 1 mole of the element. So now your answer will be in moles of the element, which is what we just found out. Now we want to convert to moles of the compound. So we can take the number of moles of element in the compound, which you guys know how to calculate now, which is based off the little exponent, right? Or little subscript. And that's per 1 mole of the compound, whatever the compound is, right? So that's a ratio you're deciding. And then you should have moles of the compound as your second answer. And we're not done yet because we're not to the mass of the compound. We just figured out the moles. But we can get to mass because we know for every 1 mole of the compound, you'll have a molar mass, which you calculate based off the periodic table in grams of that compound. And that will be what your answer is in, right? Because these will cancel, and the other two cancel. So that's the formula. I kind of squished everything in here, so let me just draw a line. That above it does not count. Everything beneath the line counts. Okay, so my question is, what mass of aluminum sulfate can be produced from 100 grams of aluminum? So in this problem, remember last semester, the naming of compounds, we learned that, right? You're going to have to figure out what is aluminum sulfate. And you're going to have to balance the charges so that you know what the correct formula is. If you guys do that, aluminum is Al, right? Sulfate is SO4. You're going to have to balance the charges. So there's Al2, SO4, 3. This is the correct compound. We want to know the number of grams of that compound. Second part, write what you know. We know there's 100 grams of aluminum. We're looking for a mass. So we're going to take 100 grams of aluminum. And we're going to start with our formula, which says find the molar mass of that element on the periodic table. What's the mass of aluminum alone? 26.98 grams. And that's for every mole of aluminum, right? 1 mole of aluminum is equal to 26.98 grams. So your grams of aluminum should cancel. This down here is just for determining what is the molar mass of the compound. So if you need to figure out that, I'm not going to go over that because you guys, I think you can pretty much do that. I listed that here so you can see my numbers. Second phase, we're going to now take our moles of aluminum that's in the compound. So how many moles of the element are there in the compound? So look at our compound over here. There's a little 2 subscript, right? That means there are 2 moles of aluminum in 1 mole of Al2SO43. So now your answer will be in moles of the compound, but we're not done yet. We now need to figure out how we can get from moles to mass, right? Moles to grams. Best way to do that, we're going to take 1 mole of Al2SO4, so 1 mole of the compound is equal to the molar mass of that compound, right? So this is where I got that number of 342.17 grams up here. I added all of them together, right? And that's of aluminum 2SO43. This is what I want my answer in, right? I want grams of this guy. Sorry, I have the hiccups. Okay, and that will give you your answer. So again, you can put this all in the calculator at once if you want to, and it should work out for you, or you could go one step at a time. That will also work. I do want you to practice. Put this in your calculator. Make sure it makes sense. If you don't have a calculator, Google has a function where you should be able to have a calculator via Google and type in what you want. It should also work. You should get 634 grams of Al2SO43. Okay, that's it, guys. There is nothing left. This is finishing the notes. Make sure you have all this written down. If you need to watch the video again, you can do it. You can pause it. If you want other help on these, again, I posted videos at the end of the module that you can watch for additional help. All right, bye, guys.